TTL Computer II. Today we'll be taking a look at our control card designs, as well as catching up on some other background activities related to the control card. And we're gonna have a bunch to go over to today. But first, I just want to wish everybody a happy, safe, and prosperous new year as we go into 2025. So, okay, I'm going to go over the card design, and not in a great level of detail since we've been doing this for a while. And so we have our control card schematic in front of us. And again, this is virtually identical to our digital simulation design, with only the addition of really the register, the register, rather the resistor networks for impedance matching from the card to the bus. And it's the only significant deviation. Taking a look at our passive elements, again, we have our uh, decoupling power capacitors, our bypass capacitors, our power light indicator, and our card edge connector. And so we can see that we have all of our control signals, or rather our clock signals, are in the standard place on the card edge. Um, Kind of have this is one of the standard places for the data. It's kind of moved around a little bit from card edge to card edge, but I have that here. We have our flags as input, and then all of our control signals coming out of the card are all here, wrapped around on both sides of the card. And yeah, we'll be talking more about the card edge connectors as we work next on the back plane. There's going to be a lot of work to do there. But so that's what the card edge connector looks like for our control card. And let's look at the PCB design. And again, so this is our PCB design, very similar to our others that we've had. Right, we have brought most of our inputs we brought up on the right side of the card. This time we usually come in on the left, but I came in on the right side, and these are all of our output elements on the right. This card was the most challenging card to do. You can see there's a lot going on, and I had to do a lot of planning to do this card, but you can see that the EPROMs, these are kind of just wired. Uh, these are all wired in parallel to kind of form up bus lines, and then the uh, the outputs are brought down. But then what I did for now, a lot of these now I just implemented the control, the microcode piecemeal as we did the digital build out. So I'd like to say like all of ROM 1 comes to the first 245 output, and all of ROM 2 comes to the second, and ROM 3 to the third. It didn't work that way, right? I had signals, coming all, all over the place. So that was probably, we could do better planning next time. But so since we kind of have these lines coming from each control ROM and crossing over each other to get to these output drivers, what I did was it doesn't look that way now, but I created uh, horizontal bus lines, uh, three of them, 8 horizontal bus lines here. That was for ROM 1, another 8 horizontal bus lines here. That was for ROM 2, and then finally another 8 horizontal bus lines for ROM 3. And then you can see as we switch to the bottom layer, you can see all of the outputs from the ROMs are coming down to what were these bus lines. And then I could, each of the chips were just pulling down, straight from the bus lines. So we didn't have to worry about any crossovers. And then once the wiring was all done, I just chopped off what was not needed on these bus lines. So these red horizontal lines are what's left of our bus lines after they were shortened up. And then these little series of bus lines here are for all of our clock and clear signals, input signals to the card. And then the one thing that I really wish I had done differently was you can see here the input control signals coming in to the LS245, the card driver, and then they're wrapping around and going over and back out this way. So I really, we're doing this over and under thing here, which probably is going to be fine, but it would have been better to bring these lines, flip this chip over and bring these lines up on this side, and then just have the output lines come straight off of this side, and we wouldn't have just had this little circular loop here that we have. But again, it should be fine. But one thing I would have changed. Okay, so that's our card. We just look at this in 3D quickly, just kind of see what we have. And that's our card. So these probably could have been shifted over a little bit more this way to bring them more in the center. But I had these shifted over because I didn't know how much area I was going to need here for trace routing. But that's another thing that I would have done a little bit differently. This could have been shifted over just a little bit to maybe here. But yeah, that's our card. And just do our check here. Right, we want to look here again that there's just a bit of gap between the actual card edge connector and the board, and there is, so the tolerance is not too tight. Okay, so that's our final card, our control board card, and that is already off to fabrication. Should get that back in a few days. And all right, so that leads us to a couple of the other activities that I had to do in relation to getting the card ready to be fabricated and tested. And one of the other things was that I mentioned was that we needed to update our program that generates our microcode so we can get that microcode into an Intel hex format so that we can get that burned to our EPROMs. So what we're looking at here is our ROM1 hex file, and this is the output from the program that generates the microcode. But this is generated what is the format that's required for digital to load the EPROMs in our digital simulation. And you can see it's just a little bit of a header file, and then each line just has one hex byte for the ROM, right? And that starts from byte 0 and goes all the way down to byte, 8192, which is here. So that all 8K bytes are there. So that's what the file looks like that the microcode program generator is doing. And I modified that. Well, it was a simple change. I just modified that to basically output assembly code, which we will use with our custom ASM tool to which we said one of the reasons we were using that was that it could generate output for the digital simulation, and in the future we could generate Intel hex files. So I changed just a simple change to output this prefix here that's used by custom ASM to indicate a numeric constant. So we have the same data, but it's just formatted for the custom ASM tool. So that again is output for the whole 8K ROM, and then we have to take that this ROM assembly file and we run that through the custom ASM, and voila, we have our Intel hex format file that is in the format that we need to burn to our our three ROM files. And I haven't done that yet, but this is all ready to go for that job. And then another thing that I've been working on is the test plan for the control card. And so this is looking a little bit different again, and a bit more of an involved test plan like we had with the ALU card. But what I'm going to do here is that, all right, so we have three 8-bit outputs from our control card. We only have one 8-bit display on our testing jig. So what I think I'm going to do is I'm going to use the same process that we used for our memory address register test, I think it was. We're going to have to go through this test plan 3 times. We'll go through one time where the display is hooked up to control 1, and then we'll run through again, and the display will be connected to control 2, and the third pass will be connected to control 3. So I'm going to do that in preference to building out some extra display elements. I don't think I think it's just going to be fine to run through the test plan 3 times. So here's our action steps that we need to take. And then again, what I've done is I've played this test plan through on our digital simulation, and I've captured the output from our digital simulation for each of the control bytes. And I've taken a screen grab and brought those in here so we can use that for a quick visual comparison when we're executing the test. And I've also have the microcode, right? Because each one of these is a microcode step. So I have the code called out here as well. But that's how the test plan is going to proceed. I just started putting that together, but that's how that's going to work. Okay, so I think that's it for today. I had a lot of things going on in the background. Also, was getting over a cold that I got for Christmas, so I'm a little behind in my video production, but I think we're all caught up. And our next video, I believe, will be testing our control card. So until then, thanks for watching.